So in the last video, we looked into the introduction to the RStudio graphical user interface. Now, this video, we will just get ourselves introduced to some basic coding in R. To start with, we can use R to do the basic simple arithmetic calculations like 5 plus. So we can start with simple calculations such as 5 plus 8, which gives us 13. Then we have 5 minus 8, which gives us minus 3. We have 5 multiplied by 8, which gives us 40, and we have 5 divided by 8, which gives us 0.625. A refresher on how I'm running this code is every time I write a code here, in order to run it, we need to press, if you're using a Windows computer, then we need to press Control and Enter. And if you're using a MacBook or an Mac OS, then you press is like Command and Return, and you run that code. Now, I mean, R can do much more than just arithmetic calculations. I mean, why use even R to do these arithmetic calculations when you have calculator? So moving on, the next things that we will look into is the data structures. So in R, in like most analytics work that we do, the basic data structure we use is something called vectors. Now, just contrary to the physics vector, it's not a set of numbers with directions. Vector is basically a collection of same type of data. So a vector can be a collection of numbers, such as suppose if we say a list of suppose next few years. So the years that is today and the next 4 years coming, that can be a vector, and that we can create that vector by creating a name, say years, and this is the indicator we use to assign a value there. And here we create so the way to create vector is starts with a C and a start of a first bracket and an end of a first bracket. So this is the syntax where vectors are created. This syntax tells R that this is not a singular value but a set of values. And here, let's say this year is 2021, then say the next year would be with the after a comma 2022, then the next year would be 2023, then the next year would be 2024. So this is a set of numbers which are the next few years coming in, and so this is a list or set of numbers stored side by side with each other, and this is basically a vector. So when we press command return or control enter, then this global environment shows that there is a vector called years, a variable called years, which is a numeric variable with 4 values: 2021, 2022, 2023, 2024. Similarly, if I say that years 2 and we put in the next 4 years, the way to create would be 2025, 2026, 2027, and 2028. And pressing again the command return or control enter gives you another vector, which is years 2, which is these numbers. Now, just similar to any arithmetic calculation, like any singular number calculations, vectors can also go through these arithmetic calculations. So it could be such as, say, if you want to do a difference between years 2 and years 1, it would be years 2 minus years. And if I run this code, so all of these years have a difference of 4 years. So 2025 minus 2021 is 4, 2026 minus 2022 is 4. So that's how we can do these calculations. Similarly, if I want to add these years to see what the addition of these years are looking like, so plus years. So another interesting thing is, as you can look, when I'm typing, R is already suggesting me these variables. How? Because it knows that these are variables that I've created and stored in the global environment. So if these variables are very complex named ones or long named ones, this way it helps me quickly pick up these variables. So when I do this addition, I get the addition of the years. So we can do similarly multiplication and subtraction. Now, a vector does not need to be just numeric. It also can be a collection of text. So suppose right now, if I want to look into a collection of text which are like, say, few names of good, like, fancy car companies. So we can have fancy cars, and here I'm creating numeric values. So when you're creating, non-numeric values or categorical values. So when you're creating non-numeric categorical text values, we start with a apostrophe, which, like, a set of apostrophe which indicates that this is not a number. And then say we go for Porsche, then say we go for BMW, then we go for Mercedes, then say we go for Aston Martin. So what's happening here is I'm actually telling R that in the variable, or in the vector fancy cars, you get to store these for a list of similar type of names, which is a non-numeric vector. And when I press command return or control enter, we have, so here fancy cars, it shows that this is again 4 values together, but instead of num it says chr, which basically means it's a character variable, or a character vector, which stores these names here. So one thing here is R will not allow you to do mathematical and non-numeric calculations together. So if I want to say fancy cars and then I want to add years to it, I'll get an error, non-numeric argument to binary operator, the similar one that we showed in the last video. So this is something R will not allow you to do. It will only allow you to do stuff such as, numeric on numeric calculation, or text on text functions. So another interesting thing is, not only can we do calculations with different vectors, but we can work with vectors and also change their values based on arithmetic calculations. So suppose I want to divide all the years in the years, like all the years in the years variable, by 4. The way to do it is simple. We give years and we divide it by 4. We get is all the years divided by 4. If we want to multiply each of these years by, say, 5, it would be years multiplied by 5. And these are all the results of multiplication. Similarly, we can do a simple addition here as well with. So here's an interesting error, that since I've typed in the wrong variable, so I'm getting years object not found. So this is a very useful thing. When this happens, you kind of go back and check whether you have typed the code wrong or not. Now when you press it, yeah, there you go, 5 added to all of them. So these are basic arithmetic operators that you can do, like run on different vectors. Another set of operators that we get to use is called comparison operators. Now comparison operators normally are basically, so we call them comparison operators, operations or operators, and they come in the form of greater than, which looks like, sort of looks like this. Then we have lesser than, which looks like this. Then we have, sorry about them, let's just make them commands. So instead of text, so we can have, this is a command which is comparison operator greater than, then this is lesser than. Similarly, we can have greater than or equal to, which would look like this, this and this. You can guess what lesser than or equal to would look like. Now, interestingly, equal to looks like, because equal to, a single equal to might be also referring to R as an assignment or a value to a function. So equal to we show by like this with 2 equal signs. And then we have not equal to, which is like this, not equal to, which is an apostrophe mark followed by an equal to. So you can guess what not greater than would look like, right? So if I say not lesser than, that would be an exclamation sign followed by the less than sign. So these are what we call comparison operators. Now let's see how they work. So simple comparison is 4 greater than 5? You know the answer, and the answer is false. No. What if we want to see that, but let's look at the use of this in a much fun way. So suppose we have years and years 2 variables. So I want to know how many years in years 2 variable are greater than 2026. So the way to do that is, so what I'm going to ask is how many years in years 2 variable or vector is greater than 2026. The way to check it is simple. We have years 2 variable, and then we put in greater than 2026. The result is the first 2 values are false and false, and the second 2 values are true and true. So what we see is we are not really getting the exact answer of how many years in years 2 vector is greater than 2026. It tells us one value at a time. It tells me that 2025, which is the first entry in years 2, is false. Why? Because it is not greater than 2026. The second one is the 2026. Now that is also giving a false result, because that means that 2026 is not actually greater than 2026. The third one, 2027, is true, which means that 2027 is greater than 2026, which is, we know to be true. And 2028 is also greater than 2026, so which is true. Now to answer this on how many years in years 2 vector is greater than 2026, we can do is we can see that 2 are not greater, 2 are false, but this is like for a vector which is like just 4 values. So we know that 2 is greater, 2 is not. But I mean, when we have millions of values here, then how can we answer this question? The way to answer this question is very simple. So this output is something called a binary vector, where in binary vector we have 2 values actually. False corresponds to 0 and true corresponds to 1. So we just add a simple function here, which is the summation function. So summation, what it does, it sums up the values in a vector. So if we put in sum and then write our questions here, is years 2 greater than 2026? What's going to happen is we'll get the answer 2. Why 2? Because the false value stands for 0 and the true value stands for 1. So together it's 0 plus 0 plus 1 plus 1. We get 2. Now interestingly, we can also do this in term here is, say, we can change the question to what proportion or say percentage of years in years 2 vector is greater than 2026. In order to answer that, so we know that there are 4 values in vector year 2, right? Years 2 has 4 values, which are 2026, 2026, 2025, 2026, 2027, and 2028. Now, what we can do is from the sum, we know that there is 2 values which are greater than 2026 out of 4 values, which is 2 out of 4, 50%. Now, that's a manual calculation. What can we do to make this whole thing just a simple calculation to get me the percentages? The answer is actually, I would say, cunningly simple. So what we do is use the mean function. The mean function, what it does is it calculates the average of numbers within it. So what's going to happen if we put in years 2 greater than 2026? So normally, what is the outcome of this? The outcome of this is basically a false and a false and a true and a true. In numeric terms, that's 0 and 0 and 1 and 1. So the mean would do is it's going to take an average of 0, 0, 1, 1, which is like 2 divided by 4, which will give me exactly 50%. Let's see if we get that. There you go, 0.5 or 50%. So this is a very nifty trick on finding out, what proportion of values are greater than a certain number, or what proportion of values are exactly equal to a certain number. So suppose I want to see what proportion of my years 2 is actually 2027. So mean of years 2 is exactly equal to 2027. And when we run this, that's 0.25, 1 out of 4. Basically, there were 4 numbers, right? 2025, 2026, 2027, 2028. Now, 4 of them, out of 4, 1 of them is exactly equal to 2027. Now, these are comparison with numbers, but what about comparison of vectors? In order to do so, let us do one thing. Let us actually create 2 new vectors. Let's call one price of a product called A. And say this price has varied like this. It has been 110 one year. So we create it using a C for the vector. Then it has been 113 in the next year. Then it has been 116 in the next year. Then it has been 112, fallen down maybe a little bit. Then say 115. So 5 different prices. So this is, say, a vector with 5 different prices. And let's say there is the price of product B, which is something maybe similar. So say it was 109 in the first year, then 114 in the second year, then 120 in the third year, then it has gone down to 115 in the fourth year, and then 112 in the fifth year. So now if I want to see which years are in what points, like how many times price of product B was greater than price of product A. So the first comparison we can do is which years had price B was, say, greater than price A. So that will be price B greater than price A. And we see that the first year it was not, the second year it was, the third year it was, the fourth year it was, and the fifth year it was not. Now, if we want to answer how many years price B was greater than price A, the answer would be, again, a very simple summation of price B greater than price A. So it's 3 years that price B is greater than price A. But now, if I want to say that, what percentage of the time was price of B greater than A? In that case, the answer, it's mean price B greater than price A. 60% of the times, price B was greater than price A. So that's a simple set of calculations that we can do on vectors, and these calculations can come in super handy, as we will see very soon. Now, the last thing is actually the concepts of if then else and loops. So these are the other 2 basic building blocks of our coding, and something we will be looking at very soon. So in the next video we'll look into that. So today it was more about introducing you to vectors and some basic operations on vectors. Again, if you have any questions, if you have any comments, feel free to share them. Hope this was useful. Thank you again for being with me in this video.